let us understand this thing once again, because every year there is one question on Kirchhoff's law, Kirchhoff's rule, for 1 or 2 marks. So what we did, we took this circuit. So in this circuit, what we did, we took 2 loops. This loop 1, this is loop 1, and what was loop 2? Loop 2 was this bigger loop. So we can take any closed loop. We can take any closed loop. We can take this closed loop as well, but loops must be closed. Loop must be closed. We can take any closed loop. So we have taken these 2 loops. What we mark, first we mark all the resistances with a current. This with I1, this with I3, and this with I2, same here as well, and this with here as well. So these resistances are marked with some current, and their direction does not matter. We try to make it as accurate as possible, but if we could not make, the current will simply become negative. So this is I1, this and this both are I3, this is I2, and this one is also I2. So now let us see what is the junction rule. From junction rule we have seen the current entering I3 must be equal to I1 plus I2. Current entering the junction must be equal to current leaving the junction. I3 must be equal to I1 plus I2. So that is true for everywhere, every junction. So here as well, current entering is I1 and current leaving the junction must be I1, because there is no other path for the current to go. Same here, if we see, if we create a junction here, that point is here. So current entering is I2, and you see current leaving this point is also I2. Current entering is I2, current leaving is also I2. So current entering the junction, current leaving the junction must be equal. Now for second rule, the potential drop, what we took, first we took this loop and then we took this bigger loop. So potential drop, if we start this point at A, and if we again after completing a loop come at this point, so potential drop or potential difference would be 0. So the algebraic sum of changes in the potential around any closed loop involving resistors and cells is 0. Or if we started traveling like this in bigger loop, again if we reached at this point A, then again this algebraic sum of changes in potential or potential difference must be equal to again 0. So now let us apply this second rule. Please remember, here they are talking about potential or voltage. So batteries or cells directly give you voltage. So this 45 or 80 can be written directly. But potential drop in any resistance, how can you know that potential drop in any resistance is equal to current multiplied by resistance? So potential drop across any resistor is simply current into resistance. So for resistances we will multiply by current and then resistance. For batteries we will simply mark directly 80, 40 or whatever the voltage is given. So now let us solve this first loop. What is this first loop? Here, here, here and comes again. So what is this? So first potential drop at this point is minus 30 I1. So I into R. Now we come at this point D. What we see? We see a battery or a cell, but this is negative, this is positive. So potential is increasing. So increasing means we take positive 45. Now what do we see? We see resistor and the current is also going in same direction. See, we are also moving in this direction, current is also going in same direction. So minus 1I3, because current here is also I3. Now next resistance is 40 ohm. So we are also moving in same direction, current is moving in same direction, 40I3. This must be equal to 0 because we have again reached at point A. So this is first equation, minus 30I, I3 and minus 40I3 and minus I3 is minus 41I3 plus 45 is equal to 0. So here is our first equation, minus 30I1 minus 41I3 plus 45 is equal to 0. So this is our first equation. Let us see our second equation. So what do we get how do we get second equation? Now we are moving like this. So let us start again at point A. So we are starting at point A. So what happens? First we are moving in the direction of current, that means minus this 30 ohm into I3. Again we come here, but if you take this junction point, so I1 we cannot take now the current I1 because I1 current is dividing into two parts. So instead of I1, what we know for sure that current I2 is entering in this resistance, and up to this point current is I2. Only thing is that we are moving in this direction and current I2 is moving in this direction. So we are moving opposite to the current. So resistance is 20 ohm, current is I2. I1, why could not we take I1? We cannot take I1 because I1 is divided into two parts, but I2 is not divided into two parts. So 20 I2 with a positive sign because current is in reverse direction. Again we come into this 1 ohm resistance. So 1, current is again I2, but we are moving like this and current is moving in this direction, positive. Now when we come at this point at the cell or battery, what we see, this is positive, this is negative. So potential is decreasing. So potential is decreasing, we put a minus. If potential is increasing, we put a simply plus. If potential is decreasing, we put a minus. This must be equal to 0. So minus 30 I3, sorry, this one is I1, this one is I1, not I3, this one is I1, 20 and 21. So plus 21 I2 minus 80 is equal to 0. So this is our second equation, minus 30 I1 plus 21 I2 minus 80 is equal to 0. Now let us read these rules now once again. Junction rule. At any junction, the sum of currents entering the junction is equal to sum of currents leaving the junction. And this is very important question. Okay, this is very important. This applies equally well if instead of a junction of several lines we consider a point in a line. So instead of a junction we consider point. So what was the point? This is a junction. This is a junction, but this is a point. This is a point, this is a junction. Here we can see three lines. Here there is only one line. So this applies well. Instead of a junction, we consider a point in a line. Now the proof. The proof of these rules follow the fact that when currents are steady, there is no accumulation of charges. That means charge cannot sit there, as we saw in case of water. So water cannot be there in pipe. Water has to go out of the pipe. So water coming in is equal to water going out. So there is no accumulation of charges at any junction or at any point in the line. So there is no accumulation, there is no collection of water in the pipe. Thus the total current flowing in, which is the rate at which charge flow in the junction, must equal to the current flowing out. So similar to water, current flowing in must be equal to current flowing out, because no charge carrier or no conductor can hold the charges inside it. Okay. Now second rule, loop rule. The algebraic sum of changes in the potential around any closed loop. So we took the closed loop and what we did, We simply took the algebraic sum of the changes in potential. How did we get that? For cells, we simply note down V like 45 or 80. Depending on the direction, it could be positive or negative. But for resistors, what we did, potential difference simply IR. We apply this rule, Ohm's law. So changes in potential around any closed loop involving resistors and cell is 0. Okay, this is 0. Why this rule is there? This rule is also obvious. How? What is the proof? Since the electric potential is always dependent on the location of the point. So there is a dependence of the location on this potential. As you have seen, there is a potential depend on the location of the point. Thus, starting with any point, if we come back to the same point, the total change must be 0, because you have seen that potential is a point dependent quantity where that point is. If we started from a point and again come back to that point, so the change must be 0. In a closed loop, we do come back at the starting point, hence the rule. So what we do? We started from this point and we again came back to this point. So the potential difference would be 0. If we have started from some other point, let us say this B point, and if we started from this point and came at A point, there would be some potential difference. But again, if we came at B point, the potential difference should be 0.